Hello everyone, and welcome back to YouTube Daily Military. The North American Aviation XB-70 Valkyrie was the prototype version of the planned B-70 nuclear-armed, deep-penetration supersonic strategic bomber for the United States Air Force Strategic Air Command. Designed in the late 1950s by North American Aviation, NAA, the six-engine Valkyrie was capable of cruising for thousands of miles at Mach 3 while flying at 70,000 feet (21,000 meters). At these speeds, it was expected that the B-70 would be practically immune to interceptor aircraft, the only effective weapon against bomber aircraft at the time. The bomber would spend only a brief time over a particular radar station, flying out of its range before the controllers could position their fighters in a suitable location for an interception. Its high speed made the aircraft difficult to see on radar displays, and its high altitude and high-speed capabilities could not be matched by any contemporaneous Soviet interceptor or fighter aircraft. The introduction of the first Soviet surface-to-air missiles in the late 1950s put the near-invulnerability of the B-70 in doubt. In response, the United States Air Force, USAF, began flying its missions at low level, where the missile radar's line of sight was limited by terrain. In this low-level penetration role, the B-70 offered little additional performance over the B-52 it was meant to replace, while being far more expensive with shorter range. Other alternate missions were proposed, but these were of limited scope. With the advent of intercontinental ballistic missiles, ICBMs, during the late 1950s, crude nuclear bombers were increasingly seen as obsolete. The USAF eventually gave up fighting for its production, and the B-70 program was cancelled in 1961. Development was then turned over to a research program to study the effects of long-duration high-speed flight. As a result, two prototype aircraft, designated XB-70A, were built. These aircraft were used for supersonic test flights during 1964 to 69. In 1966, one prototype crashed after colliding with a smaller aircraft while flying in close formation. The remaining Valkyrie bomber is in the National Museum of the United States Air Force near Dayton, Ohio. Background: in an offshoot of Boeing's MX-2145 crewed boost glide bomber project, Boeing partnered with RAND Corporation in January 1954 to explore what sort of bomber aircraft would be needed to deliver the various contemporary nuclear weapons under development. At the time, nuclear weapons weighed several tons, and the need to carry enough fuel to fly that payload from the continental United States to the Soviet Union demanded large bombers. They also concluded that after the release of the bombs, the aircraft would need supersonic speed to escape the critical blast radius. The aviation industry had been studying this problem for some time. From the mid-1940s, there was interest in using nuclear-powered aircraft in the bomber role. 2-3-N1. In a conventional jet engine, thrust is provided by heating air using jet fuel and accelerating it out a nozzle. In a nuclear engine, heat is supplied by a reactor, whose consumables last for months instead of hours. Most designs also carried a small amount of jet fuel for use during high-power portions of flight, such as takeoffs and high-speed dashes. Another possibility being explored at the time was the use of boron-enriched ZIP fuels, which improved the energy density of jet fuel by about 40%, and could be used in modified versions of existing jet engine designs. ZIP fuels appeared to offer sufficient performance improvement to produce a strategic bomber with supersonic speed. WS-110A, the U.S. Air Force, USAF, followed these developments closely, and in 1955 issued General Operational Requirement No. 38 for a new bomber, combining the payload and intercontinental range of the B-52 with the Mach 2 top speed of the Convair B-58 Hustler 5N2. The new bomber was expected to enter service in 1963-6. Both nuclear and conventional designs were considered. The nuclear-powered bomber was organized as Weapon System 125A and pursued simultaneously with the jet-powered version, Weapon System 110A. The USAF Air Research and Development Command's ARDC requirement for WS-110A asked for a chemical fuel bomber with Mach 0.9 cruising speed and maximum possible speed during a 1,000 nautical mile, 1,200 miles, 1,900 kilometers, entrance and exit from the target. The requirement also called for a 50,000-pound, 23,000 kilograms, payload and a combat radius of 4,000 nautical miles, 4,600 miles, 7,400 kilometers. 9. The Air Force formed similar requirements for a WS-110L intercontinental reconnaissance system in 1955, but this was later cancelled in 1958 due to better options. In July 1955, 6 contractors were selected to bid on WS-110A studies. Boeing and North American Aviation submitted proposals, and on November 8, 1955 were awarded contracts for Phase 1 development. The missile problem, the B-70 was planned to use a high-speed, high-altitude bombing approach that followed a trend of bombers flying progressively faster and higher since the start of crude bomber use. 31. Through that same period, only 2 weapons proved effective against bombers: fighter aircraft and anti-aircraft artillery, AAA. Flying higher and faster made it more difficult for both. Higher speeds allowed the bomber to fly out of range of the weapons more quickly, while higher altitudes increased the time needed for fighters to climb to the bombers, and greatly increased the size of the AAA weapons needed to reach those altitudes. As early as 1942, German flak commanders had already concluded that AAA would be essentially useless against jet aircraft, and began development of guided missiles to fill this role. 32. Most forces reached the same conclusion soon after, with both the US and UK starting missile development programs before the war ended. 33. The UK's Green Mace was one of the last attempts to develop a useful high-altitude AAA weapon, but its development ended in 1957. Experimental aircraft. The XB-70s were intended to be used for the advanced study of aerodynamics, propulsion, and other subjects related to large supersonic transports. The crew was reduced to only the 2 pilots, as a navigator and a bombardier were not needed for this research role. The production order was reduced to 3 prototypes in March 1961, with the 3rd aircraft to incorporate improvements from the previous prototype. The order was later reduced to 2 experimental XB-70s, named Air Vehicle 1 and 2, AV-1 and AV-2.